Yeah. So for the step 3, the crossword counterfactual, the crossword here that we uh, indicate of the exhibit of the the expectation of y1 and m0 here, because it's like a different perspective and it is not exist in the real world. So we say about the crossword here. Um, this is the key here to estimate the expect of the y1 and m0. So we follow like 3 steps here. First, that we fit the weighted marginal outcome model. Importantly, it is the marginal model with no random intercept, except that uh, I'm sorry.
Okay, I have a question. So you are writing the predicted value, the top one is fine.
Yeah.
You are saying that for subject A equal to 0, predict outcome as if A equal to 1.
Hmm.
That will be the counterfactual, right?
Yeah.
Okay.
Yeah.
Yeah.
So So we fit the marginal model with no random effects, estimating the population average effect instead. For the second one that we predict for the subject with the A like exposure equal to 0, we predict their outcomes as if A equal to 1. Yeah, like as if the exposure is 1. We give their observed mediators and confounders, and we only change the exposure variable here. We saw it here. Yeah. The third one that we take the weighted average of these prediction among the exposure groups. Um, the critical side, the critical insight is that the M0 does not appear explicitly in the formula because it's embedded in the prediction. Since we restrict the A equal to 0 subjects, their observed mediators equal to M0 by the consistency assumption. So with that said, this avoids specifying any mediators model. We use the observed mediators value directly, and which is the major advantage when mediators model themselves would suffer from like non-collapsibility in a multi-level logistic setting.
Okay. The question is that um, the weight function, when you are computing the weight, SWIJ,
Mhm.
okay, here is the indicator function. Indicator function AI equal AJ equal to 0. I is the indicator function, right?
Yeah.
So take the value 1. What is the indicator function I Aij equal to 0 equal to 1?
You mean
The value, yeah. What is I Aij equal to 0? That is 1.
mm, uh, this is because of the
No, no, no. I'm asking what is the value of I Aij equal to 0? That I'm asking. In the expected value, look at the numerator or denominator.
mhm.
You have written I Aij equal to 0.
Yeah, I see. I see. Yeah.
What is meant by that?
Um, because um,
Not because I'm asking you a question. I'm not asking you the reason. I'm asking the question I Aij equal to 0. What is the value of that? Not because. The answer should be either 0 or 1. What is the value of that?
um, the value of that um, this is like we multiple the numerator of the indicator is like 0 and 1 for the weight here.
No. Okay, let me ask you this way. That I look at the equation, expected value, that the average, that equation. You have written I under parenthesis aij equal to 0. The value of that indicator function either is 0 or 1.
Yeah,
Now, when the value is 1, that I am asking.
yeah.
Not
Uh,
here. I am asking you. Give me the answer.
so the indicators of the IAG is called 0 actually is the function of the indication that is selects the unexposure groups. Um, so when we need b- because the observed mediator value um, is the reality is that the M0, so exactly the mediator's distribution we need for the crossword. This is the mediator distribution that we need for the crossword counterfactual. So uh, after that we predict what their outcome was could be I'm sorry, let me rephrase. Could have been under a equal 1 given us the expect of the y1 and m0.
Let me see. Go back. Let me see SWIJ.
Go back to see.
SWIJ. Go back. Go back. Yeah, no. Up. Yeah. Okay.
So this is the like I a equal 0. So if it equal to 1 when the subject for the crossword it equal to 1 when the subject has the unexposure, and it's equal to 0 when the subjects is when the exposure equal to 1. Yeah, this is like the crossword for the causal factual.
Hmm.
Yeah. So for shock it's just like the I a I I of the aij equal to 0 is just like an indicator function that select the unexposure groups here. So I think that for this slide, the slide 27, that I will like email you in the detail about the formula. You think uh, this is fine, right? During today or tomorrow.
You are computing the expected value of y. So it
Mhm.
should be the value of y times some probability, which you are doing that. The probability is basically the weight function. The weight function is involving, remember that somehow I have to incorporate m equal to 0 in the right side of this expectation. Uh, yeah, m equal to 0. So what I
Yeah,
am trying to figure out, where are you using the fact that m0?
yeah, yeah,
That is my question. Weighted average predicting value equal to 0 group.
yeah, sure.
Okay.
Yeah. I try to produce I try to provide you answer like persuasively. Yeah.
Here it is, you have written M0 does not appear explicitly because it is embedded with Y hat. Since we restrict I is equal to 0 subjects, they are observed M0 with the consistency assumption. Okay. I think the role of M0 is in computing Y hat. Am I right?
Yes. Right. Yeah.
Yeah. Okay.
Okay.
Yes.
Yeah. So for the continuously, yeah. So how our method like
Hey,
WMT,
you have missed all types of references. All these things should be referred properly.
yeah.
Otherwise, it means that you are doing this, means that you are basically proposing this model, which is not correct.
Hmm.
You have taken this model from the literature, so give the references of
Yeah.
all these expressions.
Yeah. Sure. Yeah. I sure that I will work until weekend and
Yeah,
provide.
move to the next one,
Yeah.
please.
The new presentation slide on morning for on the Monday for you. Yeah. So so how the our method handles the multiple level data, the multi-level data. The WMD method is handle clustering through like two component strategy. For the point estimate that we use a weighted marginal outcome model, the cluster level covariance as the fixed effect and the invert probability weights balance confounders. So and then for the variance estimate, we use the cluster bootstrap, which resemble entire cluster to preserve the within cluster correlation here. So this approach is the analog to use the robust cluster standard error, but with the bootstrap providing for the finite sample valid inference. Uh, and then uh, when the final step that we compute the natural direct effect and natural indirect effect, that with all the three counterfactual means in hand, the natural direct effect is just a difference of the expectation of y1 m0 and y and expectation of the y0 m0, and then the natural indirect effect is the difference between the expect of the y1 m1 and the y and the expect of the y1 m0. The total effect decompose exactly as the natural direct effect plus natural indirect effect here. So we extend for the binary outcomes. That is here that we extend to the binary outcomes. The outcome model is the weighted marginal logistic regression. The parameters are estimated via the weighted estimate equation with no random effect, and this is give us the population average effect. Uh, the prediction yields the probability, and the counterfactual means represent the risk here. The natural direct effect and natural indirect effects are on the risk difference scale. The key here is that operating on the probability scale to avoid the non-collapsibility of the odds ratio entirely. So because like in the real data set that we have the multinomial outcome, so we extend to the multinomial outcomes uh, with the categories here. Um, that is we using the multi-level uh, multinomial logistic model
But why
regression.
do you need multinomial? How many categories do you have?
Three. So we have three.
What are those?
So this is about the related to soccer rhythm. So this is like the fibral the fibrally kind of two of the non-suckable rhythms, like two type of non-suckable rhythm that we can separate, and the last one is the suckable rhythms, the fibrillation and the pulseless electric activate activities. Yeah, and the last one is the shockable rhythms of the heart. So we have like three categories here. For binary, that we just simply separate like the unsuckable rhythms and the suckable rhythms. Yeah. And then, so the reduction here is use the vector of categories probabilities, and we compute the categories is specific, the uh, natural direct effect and natural indirect effect here. This is the same one. Yeah.
Yeah.
Yeah. So in the weighted marginal decomposition framework, the multinomial outcome model is a weighted marginal multinomial logistic regression. Again, that we use the no random effects and we estimate the categories specific probability using uh, the function here. Yeah. And the natural direct effect and the natural indirect effect is compute on the probability scale for each categories. The same key advantage apply that we operating on the probability avoid the non-collapsibility across all of the categories simultaneously. So for the variance estimate, given the multi-step estimate procedures, the variance calculation is intractable that we use the non-parametric cluster bootstrap here. So we just like resample the cluster with displacement, rerun the entire estimation pipeline, uh, including like propensity score, the outcome model prediction, and the effect computation here. And we construct the 95% of the confidence interval from like 2.1 and from the 97.5 percentile. I'm sorry, like 2.5 and 77.5 percentile. The cluster bootstrap preserve the within cluster dependence. So this is like capture the normality of the natural direct effect and natural indirect effect sampling distribution here. Yeah.
Okay.
Yeah. So here is that we compare between like two methods, the modified Mackinnon method and our method is the weighted marginal decomposition. This table summarize the keys difference. The Mackinnon operate on the product of the coefficient framework on the standardized log odd scale, while the WMD operate in the counterfactual framework on the property scale. So Mackinnon handle crossword quantities on underlie of the linearity, while uh, our method like WMD estimate them. So Mackinnon does not address the non-collapsibility, and our methods like WMD avoid it entirely through the marginal model. The key here is that our method WMD is operate on the probability scale and is directly interpretable. It's estimate on the required counterfactual quantities. So to summarize that, the WMD framework that we estimate the propensity score fitting the weighted marginal model predict under counterfactual treatment average to get the natural direct effect and natural indirect effect on the probability scale. And then lastly, that we bootstrap the cluster for the confidence interval. So uh, this workflow is the simultaneously handle clustering, handle multi-level data, multiple mediators, and categorical outcomes, and can avoid the non-collapsibility here.
Yeah.
Yeah. So here is the uh, also the important work is about the simulation study. Um, so the method is performed on the control setting that for the simulation study, we have like four questions. First one, that how do the method compare in terms of the bias? Second one, that do confidence interval achieve for the nominal like 90 to 95% coverage? And the third one is how does the performance vary within the sample size and the intra class correlation coefficient for short color ICC. And last one, do the finding generalize from the binary to the multiple outcomes, multinomial outcomes. And I use R for doing this. This is like, and because to shorten the runtime, so we use the parallel optimization to speed up the process. So here is the data generation mechanism. So we
Are
simulation.
you following any special techniques to generate your data or just the model?
Um,
Any software, anything like that?
uh, so I program it in R, yeah, and the framework is quite not similar, but like uh, from the paper that I should cite here is the Mackinnon. He used for just the like the outcome is the continuous one.
Yeah.
Yeah,
Okay.
yeah. So I should try here. Yeah. So this is just for the model, I think. Yeah. So so we simulated the scenario of like 2-1-1, which means the exposure to the mediation and to the outcomes the like a cluster level exposure is 2, and the mediation and the mediator is just at one level, and the outcome is just at one level. So we have like two binary mediators and a binary or multinomial outcomes with 8 confounders. The mediators and the outcome models are the random intercept logistic regression, and the ICC is controlled by vary the random intercept variance using the formula sigma square equal to ICC times the pi square over 3 divided by -1 here. That 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 in the slide. Um, so it's quite of the factor design that we got uh, 96 condition because we have a 6 factor like 3 level of the number of groups, uh, 20, 50, and 100. 2 level of group size, the small like 5, 10, or moderation like 20 or 30, and mediators ICC like low and high value, and this is like the same for the outcomes of ICC is like low and high, and we got the A pathway effect size small last and B pathway effect size small last. So that's why we got like 96 condition, and we ran like 300 replication per condition with the fixed direct effect of the C prime equal 1. The through effect were computed through the Monte Carlo integration with like 30,000 draw. These are population parameter independent of the study sample size. So here's the matrix that we use to compare. We use the bias, the relative bias, the root mean square error for accuracy, and the covert rate, the empiric standard error, and convert rate for inference. So our target is the coverage is approximate like 90%, and the bias is near zero here. Here's the results for the binary outcomes. This is the overall performance through the 96 binary condition. For the natural indirect effect, the Mackendon has the bias like 0.107 with the 32 coverage. The WMD has the bias like 0.025 with 83% coverage. For the natural direct effect, the contract is even like different. Mackinnon has the bias like 0.38. That is 51 times larger than the WMD bias because the WMD bias is the negative 0.007 here. Yeah. And so the Mackinnon natural direct effect coverage is just like 24.4 and below a big difference compared to the target of the 90%, and WMD is achieved like 92.1% here. So, and both methods converge like 100% of the time. So this is purely the estimated accuracy and the coverage validity. Yeah. So for the binary results, this is the performance by the sample size. Here that reviews the finding of the simulation. The Mackinnon natural direct effect coverage the set as the sample size increase, it's just like 58% for the smallest configuration and drop to 27 and drop to 27 percent, 8.7 and 10.7, and finally just like 0.4% for the largest sample size. So this is the key finding. The Mackinnon coverage wasn't with the largest sample, and so for the consistent estimate, the coverage should improve and at least like stabilize for the more data. So it wasn't mean the this is the Mackinnon's fail of the estimator. In contradicts, the WMD maintained the coverage between like 90 to 96% across all the configuration here with the bias consistent like nearly zero. So that's exactly that we want here. For the coverage probability, so for the blue line, for the blue is the our method like WMD. For the red is the Mackinnon method, and the dashed line here is the natural indirect effect, and the solid line is the natural direct effect. I'm sorry, the dash is the indirect effect, and the solid is the direct effects. So the red line is so the Mackinnon coverage is like looming like below the number of the loops when the loops increase for both large and small loop size. The blue show the WMD line remain stable nearly like 95% target across all the condition. The dashed line is the natural indirect effect, and the solid line is the natural direct effect. Is that uh, the net the natural direct effect of the our method WMD is coverage is nearly consistent, nearly nominal at the 92%, while the natural indirect effect coverage is slightly lower, around like 83%, reflects greater difficulty estimate the indirect effects, but still vastly superior to the Mackinac, just like 32% here. We saw the root mean square error comparison here. Uh, so this is telling the practical story. The root mean square error is like 11 to
What is WMD? That is your inverse proportion, right?
yeah.
The W that you computed based on that. Okay.
Yeah. So we saw uh, the ratio is like 11 to 18 times
তুমি কি
lower than the
খাবার
Mackinac.
দিচ্ছিলে?
So this is depend on the condition. This means that Mackinac would need like 11 to 18 times more data to achieve the same precision as the weighted marginal decomposition method. Uh, even though that uh, even that we need the bias would remain. So here's that we saw the proposed net compare in the ICC circumstance here. So the WMD maintains like 91 to 93% of the natural direct effect coverage, regardless of the ICC configuration, whether mediator's ICC is high or low, and whether the outcome ICC is high or low. And Mackinac failed uniformly at the 21 to 27 cover percentage coverage, and why the robustness of the WMD is at the high level of the cluster, like greater than 90% here. uh, so with that said, for the multinomial simulation designs, that we have like three categories outcomes, and the data generating model using the multinomial logistic regression with category specific the coefficient and random intercept. So we evaluate the categories specifically natural direct effect and natural indirect effect for both categories uh, compared to the reference group. We have the same 96 condition factory design with like 300 replication like in the binary outcomes as well. Here's the result for the overall performance for the multinomial outcomes. The weighted marginal decomposition achieve the coverage of the 92 to 94 across all the four effects here. Mackinac coverage range just from 44 around 44 for the first of the natural indirect effect down to 60% of the natural indirect effects of the second. So with the natural direct effect coverage is just like at the 84 to 88%. The bias difference are also like dramatics. The weighted marginal decomposition bias are the order of magnitude smaller than the Mackinac for all of the effects. Here's the worst of the worst scenario of the natural indirect effects of just of the first category compared to the reference group here. So For short case study, the first natural indirect effect result illustrate the worst case scenario through indirect effects for the category 1 is only like 0.005, essential like nearly zero. Mackinnon is estimate like 0.0465. The relative bias is of the positive like uh, 830%. So we saw that because we saw the small gap, but it's like it's for the relative bias is quite big here, very big. It's detect the strong indirect effects where almost none exist. We saw even though the relative effects 100 more, percent more for the weighted marginal decomposition with the through with the through bias is the 0.104, but we it is sound last, but this reflect nearly zero for the denominators. The absolute bias is just like 0.0054 here. So for the so I'm sorry. So for the practical implication is that Mackinnon could lead to completely wrong conclusion about the mediation uh, and finding the pathway does not exist here.
Okay. But this Mackinac guy, he has not done the causal inference, right?
Yeah, no,
Yeah.
yes, yeah. So here the heat map uh, so the corporate different combination between groups and outcome ICC. We saw that the weighted marginal decomposition maintained the yellow color. The coverage is nearly uh, yellow color is the 100 and become like orange, and the red one is like zero. That is we saw in the Mackinnon show red and orange, the low coverage, especially for the natural indirect effects. Uh, Number one, like for the category 1, that we drop, it is dropped to 17% under high ICC condition. And this is the and on the table of left side, just citing the example incorporate between the ICC mediators and ICC outcome that is combined between low and high of the ICC, and we saw the superior of the coverage of the weighted marginal decomposition method here. So for and on a log scale, the mean square error comparison here that we saw is substantially lower than of the weighted marginal decomposition, lower than the Mackinnon for all the indirect effect and most of the direct effect. The like for the 14th floor mean square error difference for the the natural indirect effects for the category 1 means Mackinnon would need 40 times more data to achieve the comparison power. And again, the bias would persist regardless. So to summarize the simulation that we saw that the Mackinnon showed the CV bias up to like 830%, coverage low as 0.4%. And this is wasn't with the large sample size and consistent failure across all the conditions, while the weighted marginal decomposition show the minimal bias across the on condition, like nearly nominal coverage, like from 90 to 95% progresses across the ICC level and the sample size. And this is like 11 to 14 times better efficiencies. So the version of the Mackinnon coverage with the sample size is the clearness indicator that this is the structural estimate failures and not the small sample problem or and it cannot fix with the more data. Uh, Last step that I apply our method to the cares in the realized data, uh, and we apply on the cares registers. Uh, we apply on the cares registries data. So, uh, so the data set is combines the CARES database from 2013 to 2022, and it's like combined with the American Community Survey data geocode to the zip code, not the census tract here. Yeah, because yeah, and we have 16,484 out of hospital cardiac arrest cases across like 44 zip code with a median of the cluster size the 374 patients per zip code. Uh, our exposure is the predominantly Hispanic area defined as the greater than 40% of the Hispanic population. And so this include like more roughly like 4,000 cases, or like 33 point, I'm sorry, 23.2% of the sample. Yeah. And then we analyze like two outcome formulation. The binary is the suckable rhythm versus the non-suckable. Uh, and the multinomial is the asystolic. The BEA is the pulse electrolytic. I'm sorry, the pulse electric activities. Yeah, shock is the BEA, and suckable. So here is the causal framework.
Okay,
The,
then again, the big question, that the arrow, the sequential thing that you started with, you did not give any solution to that arrow,
Mhm.
that M1 goes to M2. Otherwise, don't say that.
Okay, I see. Yeah.
Yeah, correlation dependency, forget it. Just M1 and M2.
Mhm. Yeah. Okay, I will fix that. So the diagram here illustrates the structure. The exposure is at the level 2, the neighborhood level, while the mediators and outcomes at the level 1, the patient level. The neighborhood composition influence the individual level bystander intervention, which in turn affect the individual level rhythms presentation here. Yeah, this is the two by one multi-level median structure that I plot it here for easy reference here. That we saw the exposure at the level 2 and the mediators and the outcomes at the level 1.
Do you have any patient that have both M1 and M2?
Yeah, I think so. It's just like a small number, yeah.
Kini?
Small small number that I can that I could like sign the number here for you. Yeah, let me do that.
Yeah, that will be some question, that you have some patients who have only M1 or only M2 and both M1 and M2.
Yeah, sure. I will sign that. So here's the results of the binary outcome results. The McKinnon detect like no significant effect, neither the direct nor the indirect effect reaching the significant here. But the WMD is tell the very different story. The total direct effect is 0.002 as not significant, like suggesting no overall direct association. But when we decompose further, the pure direct effect is like 0.038 and it's significant. meaning that Hispanic neighborhood actually have like 3.8 percentage point higher probability of the shock algorithms holding the mediators fixed. The total indirect effect is negative 0.033 and significant. This means that the mediator pathway suppress disadvantage of by like 3.3 percentage point, and the WMD confidence interval 78 narrower than the Mackinac under uh, of the Mackinac confidence interval.
Now, what is meant by pure direct and total indirect, pure indirect? What are those things? These are the new words now.
Yeah. So the purest direct effect so so you may so we remember that the formula like expected of the M1
No,
uh,
but did you use the word pure direct? Where did you use that word? Pure direct, total indirect, pure indirect. Did you use in your text those definitions?
no, in the method that in general that I need in general it's just I use the natural direct effect
Yeah,
and then
exactly. So here you are using, instead of natural, you are using the pure. Don't do that, because I nobody knows what is meant by pure, what is meant by total indirect. You have used natural direct, natural indirect. Whatever the words you have used over there, use here also.
yeah,
Or if you want to have, then you have to define it first. What is meant by pure direct? What is meant by total indirect, pure indirect? I know only the natural direct, natural indirect, when it is a causal mediation analysis.
yeah, I see.
Yeah, stay with the same, um, what is called the terminology. Don't change.
Yeah, I see. Yeah,
So the thing is that obviously, um, causal inference is giving you more. You are getting 2 years, and Mackinnon, that thing is, everything is no.
yeah, right. Yeah, yeah, and and for that results that I plan to invite the PI, the doctor in uh, the former like UIC Health, the UI Health of the one of the PI are from the Department of Emergency in our committee as well. So she will saw the results here. So we saw that for the clinical
Let's
interpretation.
go move forward. What is there?
Yeah. So the finding here is has the important clinical implication. The
Okay, so he'll be happy. That's very good. Let's move forward.
Yeah, sure. Yeah. So I will invite her. Yeah.
Now, I have a question that all these 72 slides are based on only one problem, right?
Yeah. Through the challenge of the like the multi level, the multiple mediators and the
Yeah,
outcome.
now my question is that is it good enough for a dissertation? Because after all, they will be seeing that you have a data, you have developed some kind of methodology for the data, you are comparing with other standard methodology that you have said, and that's it. So, and so these are all summary of the findings. You have done some simulation study. Based on that, you are um, analyzing your data and then give the interpretation. Okay, I understand all these things. But question is that is it good enough for a uh, for one PhD dissertation? That is a question. Mechanism method completely missing this finding. Okay, completely missing. That's okay. So go back. Sorry, go forward. Go forward. Move forward.
Yeah.
No, move forward, not back. Move forward. Go forward. Go. Okay. So here it stops. Okay, I got it. I don't know. The thing that you have done, probably it's okay. I don't see that many problems. But somebody may ask you this question: is it good enough for a PhD dissertation? Uh, Generally, even if we go for, say, two problems, generally they look for three problems. But I cannot see more than one problem that you have solved. You have this causal mediation, then you are looking at the standard methodology, which is not causal mediation. Then you are talking about the binary data for hierarchical model with multiple basically two mediators, and for binary outcome as well as binary exposure. Okay, that's fine. Then you are going through the weight function, which is again the what kind of weight that it is the logistical weight,
Yeah.
which is called, what is the name of that weight?
The stabilized weight. The stable
Yeah,
weight. Yeah.
stabilized weight. So you have stabilized that, and using all those things, you are estimating the direct and indirect effect, and then you have done the simulation and showing that your model is robust, your model is doing good, and so on. Then using that model, you are using your data analysis, and then you have found something significant, which is good. But other method, which is not even the causal mediation, cannot detect anything. So you are happy, which you should be happy, and that's the end of the story. The question is that, is it good enough for a PhD dissertation? That is the question coming. And the committee members, who are the committee members?
So Dr. Basu, uh, the the Dr. Basu and Saria, like Adawala Saria, and Mike and Michael Bobom, and then and co-director of the MIC, the methodology research score, like
Okay,
Oxana
got
Peters,
it.
yeah, and the PI, the former PI in this project is the doctors Ma- Marina De Rios,
Hmm.
yeah.
That is the only question. But anyway, I do not know the answer. As such, I don't see that. As such, I'm encouraging you rather to give the proposal and then decide. Then they will decide what to do. Okay.
Yeah.
Now fixing the date. So when are you planning to give the proposal?
Can it be on the middle of the April, like
Middle of April. I'm coming back. I'll be out of town. I'm coming back. I think 20th of April.
yeah, 20 of April?
After
So
that is fine.
yeah, so so maybe on the week of like 20 to 20
Yeah, that's
fourth,
fine with me.
maybe on Wednesday or Thursday. Is that work for you?
Yeah, that's fine with me.
Yeah.
Okay,
Okay.
then.
Okay.
Yeah, take care of those changes. And I'm not sure whether this is sufficient for a PhD dissertation, but the committee member will tell that. And if they want some more work, you should also think that what will be the more work. You can think about using that Dev's. Did you use Dev's approach?
Yeah, I compare the depth approach
You
in
can
my.
put it down the comparison, because your this Mackin guys, their method is not for causal inference. Am I right?
Yes, right.
Then comparing with the causal inference of Mackin method is not meaningful. One is not causal method, then what is the point of using that? Rather, use Dev's method and compare, and that is the future study. You have already done that, but you write it down that I'd like to compare with another causal method, give the name of Dev's method, and I would like to compare my method with this method. What are the difference of that method, and so on and so on, and then put it in the few slides, and then later on you put that in your dissertation.
Mhm.
So as if that you are giving the proposal, but you have some work in hand that you are going to, but don't show any result. Just put some slides that I want to compare with some other causal method to see whether my approach is working compared to the other standard causal methods. Okay?
Yeah, sure.
Okay. Then that will be meaningful. Then people will see that, yes, you are planning to do more work.
Mhm. Yeah.
Okay, then.
Okay. Yeah. So thank you, Dr. Bumi. Yeah.
Thank you.
See you then. Yeah. So I will contact Liliana about the.
Yeah, Liliana, let her know, take care of all the comments, then add the Dev's method, but don't show the results, and that is your future work, and
Mhm.
so on. Okay?
Yeah, sure. Thank you, Dr.